Hi, grade 7. This is a video for Chapter 6 test, Form 2C, which is a practice test, getting you ready for the test that's going to happen the next day. Number 1 says classify the angle pair below using all the names that apply. I would highly suggest for number 1 you look at page 256. That could help you considerably. Number 2 says classify the triangles below by its angles and by its sides. If you're trying to solve that one, I would look at 263, where they talk about how triangles can be classified according to their angles as being acute, obtuse, or right, and they can be classified according to their sides by being called scalene, isosceles, or equilateral. Number 3, find the value of x in each figure below. Find the value of x. Well, if I had a figure that looks like that, and I was told that this angle right down here is 40 degrees, how could I figure out this angle? Well, together the two angles have to equal 180. They have to, because this is a straight line. So I would think to myself, x plus 140, and I would ask myself, what does x have to be? I'm sorry, x plus 40 rather. What does x have to be? X has to be 140 degrees. And it's a pretty big angle, isn't it? It has to be 140. How about number 4? What do I got there? I've got two parallel lines. And they're asking you to imagine, what if this is 70? What would this be? Well, I'm not going to do 70, but what if this is a 50-degree angle? What would this one have to be? Well, let's think through this. In your book, they talked about something called corresponding angles. Do you see how this one and this one have to be identical? Because they're in the same position. They're on the left side of the parallel line. And that's called being corresponding angles. Now, if I want to know what this one is, let's ignore this one now. And let's ask ourselves, what does this angle and this angle have to equal together? Don't they have to equal a straight line or 180 degrees? So if this is 50 degrees, this one has to be 130 degrees. So that's similar to number 4. 5 and 6, remember, the sum of the angles of a triangle equals 180 degrees. And number 6, the sum of the angles of a four-sided polygon equals 360 degrees. 7 and 8, they're talking about those two special triangles. They talk about that on 267 and 268. But let me try to give you a quick review about that right now. Remember that if I have a 30, 60, 90 triangle like number 7, it has some special properties. 60 degrees, 30 degrees, 90 degrees. If I know, for example, that this side right here is 10, can I figure out all the other sides? Yes, I can. The shortest side is always called A. The second shortest side is always called B. And the hypotenuse is always called C because it's opposite the right angle. And it's also the longest side. The rule about 30, 60, 90 triangles is that if you take the smallest side and multiply it by 2, you get the largest side, the C value. A times 2 gives you C. 10 times 2 is 20. If I know that, I can use the Pythagorean theorem, and I can solve for the value of B. And they want that in 7 and 8. In 7, they want you to figure out the length of A and B. In 8, they want you to figure out the value of A and C. Now, be careful. In 7, they should have called AC, but that's neither here nor there. Okay, so what do we got here? This would be 100, 400 plus B squared. Let's subtract 100 for both sides. B squared is 300. Let's take the square root of both sides. Using a calculator, we get a B value of, what does that equal? Well, it's smaller than 20, but it's bigger than 15. 16 would be 250. I don't know. Calculator time. That one I can't figure out in my head. I get 17.3. So B would be 17.3, and C in this case would be 20. Okay, don't forget that with number 8, when you have 45, 45, 90 triangles, the two legs, the A and the B value, are always going to be equal. And then to figure out the other one, use the Pythagorean theorem. 9 and 10. If I were thinking about 9 and 10, I'd be looking at page 273, where it talks about the different types of quadrilaterals. Is 9 a quadrilateral, a trapezoid, a parallelogram, a rhombus, a rectangle, or a square? What about number 10? What would we call that thing? 11 and 12? Well, they say in the directions that triangle TUV is congruent to triangle WXY. And notice how T is listed first in its name. So that must mean that T is corresponding to W, and U is corresponding to X, and V is corresponding to Y, right? And if that's true, then number 11, we're finding the length of WY, and number 12, we're finding the measure of angle X. Okay, next page. Number 13, which of these Greek symbols below have line symmetry? In other words, you can either draw a line vertically or horizontally to cut it in half, and the one side looks exactly like the other side. Number 14, if you looked at a square, a rectangle, and a trapezoid, which one of them would have rotational symmetry? If you need help with that one, I'd suggest you look at 273 for examples of those things and think about rotating them. 15 through 20, talk to me if you have any troubles, but hopefully you'll understand how to do them. Remember, they want you to do reflections, translations, and rotations there. Bye-bye.